I'd like to start by finding how many industrial hygienists are in this room. Put your hand up. 1, 2, okay, this is going to be fun. It's going to be really fun. So the application of prevention through design to construction has been remarkable. I'm always very impressed to hear the kind of things that we have been implementing flawlessly in construction. We've applied now prevention through design to machine safety, to working at heights, for instance, and to even have it applied to ergonomic hazards. We have not made significant progress to design out industrial hygiene hazards. Yes, there's some good examples. I came out of big pharma, and we have done a really good job of designing in to the synthesis process and then to the drug manufacturing process and packaging, prevention through design concepts. And that was important because those drugs these days are very, very potent, and high potency drugs means they can be very toxic if the exposures are not controlled to the workforce. And there are some other examples, for instance, ionizing and non-ionizing radiation. There are requirements, there are very rigorous standards for controlling ionizing radiation exposure. And so for the industrial hygienist, it's simply a measurement of what their dose is. And then you can verify that the containment for the unit is intact. However, for industrial hygiene, that's essentially it. And so what I'm trying to look for are opportunities to use prevention through design to expand what you have done for construction to industrial hygiene hazards. And I hope that my remarks are going to spark a lot of debate and discussion. So I've listed the elements of the Prevention Through Design Standards, section 9.1, on this screen. And so what I want to do is walk through the steps as defined by ANSI by grouping them into the industrial hygiene exposure assessment process and risk communication and control. That's how industrial hygienists refer to these elements. Let's begin with the industrial hygiene exposure assessment process. The first 5 steps of the standard for PtD. I'll focus on 2 hazards during my conversations with you, noise and chemical agents. So while noise hazards are fairly easy to identify, obviously, if you have good hearing, you can hear it, and there are even little apps that you can put on your phone that can help you identify when there are noise exposure risks in your work environment. However, chemical hazards, and even identifying the hazard, requires that people look at a safety data sheet. And they have to have some good understanding of toxicology, including the routes of exposure to the chemical, and can I get it through the skin route? Is it an inhalation route? And then if there's any kind of additive or synergistic effects associated with other chemicals that they might be working with. That's multiple agents. And then there are even chemical agents that are called ototoxic. For instance, toluene is one. Toluene can affect the hearing. And so you need to also look at other noise exposures in the work environment and maybe their toluene exposure to fully understand the risk to their hearing. So the industrial hygiene process is measured during normal operations after the equipment has been designed, procured, installed, and is qualified. That's when we come in with our little sampling equipment and we start to measure exposure. And we do it by looking at an 8-hour time-weighted average. We look at short-term exposure limits, which are 15-minute time-weighted averages, or ceiling concentrations. That might be like for carbon monoxide, for instance. You want to make sure that people don't have exposure to a high concentration that can cause immediate health effects. Then exposures are compared to an occupational exposure limit. So we already talked earlier today, someone mentioned that the OSHA PELs, the permissible exposure limits for chemical agents, haven't been updated since 1970, and they won't be updated. But then do we have the ACGIH TLVs? Do we use that? OSHA doesn't look at the TLVs. OSHA looks at the old outdated PELs when they do inspections. Do we look at a NIOSH REL? That's a recommended exposure limit. Yes, we should as well. But now the EPA, ECHLs, is where really you have to start to look, and this is new chemical entities as well, for their interpretation. So it becomes really very difficult to even establish what that exposure should be measured against. So the next 4 steps in the standard relate to the IH process for risk communication and control. The first is worker notification. And let me tell you how uncomfortable it is for me to sit down with a worker or a group of workers, because they're all exposed to the same agent, and inform them that they've been exposed above a permissible exposure limit or a threshold limit value. And that then prompts me to have to prescribe personal protective equipment for noise, obviously hearing protection, and then for chemical agents, it may include respiratory protection if there is indeed a respirator that's been approved for the chemical agent to which they're exposed. Then we have to go to medical surveillance for those individuals. So if somebody is exposed to noise even for 1 day in a year, over 85 decibels, they have to be in a medical surveillance program for noise-induced hearing loss. So that takes a whole lot of effort on behalf of the industrial hygienist to be able to measure and do all, to implement all of that. Then there's periodic resampling, worker training, and compliance auditing that must be done. And then finally, we get to the point where we're going to reduce the risk. We're going to have to retrofit. But we're tied up so much in the other aspects that retrofit becomes far off in somebody's mind in what they need to do. And that's why we rely so heavily in existing operations on using personal protective equipment. So let's go on to using the hierarchy of risk treatments that is in the standard. The first is, obviously, we want to get way up to the top of the hierarchy to avoid and eliminate. Ain't happening with a process that's already installed and in your work environment. You cannot redesign a process, for instance, a production process. At Amazon, we have t-shirt printing process. I can't go to them and say, change all those dyes or change the fixative solutions. That's needs to be done way up front during the design of the process. Then the next thing you want to look at is whether we can substitute. You can't substitute anything, obviously, if it's in production. Unless you have maintenance. Maintenance activities, usually you can substitute. They're cleaning, maintenance chemicals, then you can substitute the agent. So that's one thing that we have to always look at. But oftentimes we don't even look at maintenance of equipment. We tend to overlook those. So then we have to focus on passive controls and active controls. Those, however, then require significant understanding of how to engineer out that exposure. Where in that process is the noise being emitted? Where is the chemical agent being emitted? For instance, what kind of local extraction systems do I need? And then trying to understand how to pilot test them and then do the return on investment so you can get funding for these things. As a result, we often resort to controls at the bottom of the hierarchy. So in 1997, Zimbersky offered that our ability to influence safety drops off dramatically as we get into detailed engineering. I can tell you from experience that unless industrial hygiene is considered during conceptual design, it's even more dramatic. It just does not, we just are not able to re-engineer a process already when it's in detailed design. So let's go back to noise retrofits. So noise-induced hearing loss cannot be reversed. Once we affect your hearing, it's there for life. Costs are also dramatically increased if we, the cost of trying to design out the controls is also very significant. Noise, however, noise-induced hearing loss is 100% preventable. But compliance with the OSHA standard, however, and alignment with the TLV, if indeed your organization chooses to use the TLVs instead of the OSHA PELs for noise, and they're different, is for that 8-hour time-weighted average. Certainly important to determine the workers that are at risk for noise-induced hearing loss, but it's not going to help you to identify where the noise is coming from and how are you going to mitigate that. So in order to reduce noise exposure risks, what we need to do is to identify the sources of the noise. But it isn't just where the noise is being emitted by a machine, and that's hard enough to do it, but also the room acoustics. So if you have a noisy piece of equipment in a warehouse environment where you have concrete floors and hard walls, you're going to have acoustics and vibration noises and reverberations that must be addressed as well. So it also requires the identification of the predominant frequencies of the noise so that you can actually select the right engineering controls. So for existing operations, you have to obtain sound level surveys and noise mapping and measure background sound pressure levels from each noise-producing equipment, and then you have to figure out how you're going to mitigate that noise. Where are you going to focus your noise controls? And many machine noise measurement standards, and they're not mandatory, they're standards, especially for those for machine tools, specify that noise is measured with the machine idling or running unloaded at maximum speed. Again, this means that noise is measured, the sound levels, they're not characteristic of what's going to happen in a work environment. They're not representative of noise that you're going to have for the workforce. And so we have to figure out how to measure the noise when it's fully loaded and fully operational. Again, how do you then back everything up to design in the right kind of controls? So it then comes down to how to control the noise. So source treatments are really the preferred option. And I only put one small source treatment up there in the upper left of the screen, obviously, so because they're so complex and you really, even if you put it in, you wouldn't be able to visualize it. But if you can't do source treatments, if you can't quiet the machine, for instance, and the noise being emitted from the machine, you have to figure out how to use path treatments. And path treatments are, barriers and curtains. You'll see panels that people will put onto concrete walls. That helps with the reverberance of noise. It also then helps with reducing the noise to associates or to workers that are working away from the equipment so that they can be removed from a hearing conservation program. So then you start to ask, are there machine emission standards for noise? In Europe, yes. Here in the United States, no. So the Acoustical Society for America has an ANSI standard, and it's just voluntary, that specifies that noise emission values be declared, not controlled. I've never seen that. I've never seen any piece of equipment with a declaration of what their noise value is. But 2006/42/EC, the European standard, requires a technical noise reduction at the source in addition to a declaration of the noise emission. That's why when you go to a European warehouse or manufacturing facility, it's much quieter. It's because they have standards that require it. So how do we get to the top of the hierarchy for noise? We have to identify the noise-producing tools, process components, and machines. We have to meet with the suppliers or the integrators of the equipment to modify the noise-producing components. And so, for instance, one of the things that I'm doing right now is working with our material handling equipment to change metal rollers in the conveyance system to coated rollers. That's a heavy lift. You think that it's fairly straightforward. Yeah, come on, let's do it. It's a lot of work. And then we have to change them out more frequently. They wear out more quickly. They're not as reliable as a metal roller. We then have to take those requirements that we have in the agreements with, for instance, the manufacturers and the integrators, and require this change, the modification in the equipment design. Because quite frankly, if it's not in the design standards, it will be removed. And you know this because we talked about value engineering, and it's a wonderful process to have value engineering, but if it's not in the standard, it will be removed. Then we have to also then include noise emission requirements in the supplier and integrator request for proposals. So we have to give them our standards and say, you will comply with this. Tell us what the cost is going to be. Then we should ask them to do the testing during factory acceptance testing, or FAT, and then during installation, and then during full operation to verify that we have achieved what we've expected in our standards. And then we do have to agree that we're going to probably need path controls as well. We'll probably have to put up some kind of noise barriers and acoustical panels because of the way technology is, and we're just not there yet with regards to keeping things quiet. So noise was the easy part. You know, this was the easy one to talk about. Let's now talk about chemicals. So chemicals, the challenge of applying prevention through design to chemical hazards is significant. We recognize that chemical concentrations can vary significantly depending on the operation, depending on the way the worker stands next to the machine, depending on their work practices, or even shifts or work days. So the current method for sampling and comparison with an occupational exposure limit is to collect samples over a work shift and then determine what that time-weighted average concentration is going to be. Some agents have short-term exposure limits or ceiling concentrations, as we talked about earlier, things with acute toxicity. Exposure variability, however, for certain agents can result in acute health effects. So how do we correlate this to the specific tasks? And that's the challenge for designing it out. So for agents with acute toxicity, what's the day-to-day exposure variation within a work shift, within a day, with the way I do it? Here's a good example. My mother taught me to bake pies, okay? Her work in her kitchen was pristine. There was not a piece of flour anywhere. There's not a particle anywhere. I make pies to this day. The whole house is covered in flour dust. I'm not sure how she did it, but it's all work practices. And so you have to factor that into the whole design of the process, because the way I work is going to be much different than the way the people at this table or this table work. And so you can't just measure one time and expect that it's always going to be the same. So what about chemicals without occupational exposure limits? At the bottom, you'll see kind of an overview, the A, B, C, D, E. Oh, excuse me. See if I can go back. Nope. How do I go back? it's going forward. Do you know how to go back? There you go, perfect. Thank you so much for doing that for me. I appreciate that. So you see that is just a little bit of a summary of the occupational exposure bans for chemicals without an authoritative OEL. So a question for everybody that's not an industrial hygienist here: just because a chemical agent does not have an OEL, does it mean it's not hazardous? No, of course not. And so we need to always think that through as well and question. That means that you have to look at the SDS, you have to be able to look at the toxicology of it, and then apply the banding principles to it so you understand how to design out the potential for exposures. So then yet again, we assess exposures after the process or the machine is fully operational, leaving us very few design options for removing the hazard or reducing the risk of the equipment. And that's why we rely so much on personal protective equipment rather than kind of engineering out the controls. So let's look, for instance, at the one that industrial hygienists most use when there's an identified hazard, and that's ventilation systems. So are there requirements in OSHA standards that you have to use ventilation systems? There are several standards. These standards, there are ventilation system information in these OSHA standards. The OSHA, there's ones, the 1926 examples, and then some examples in 1910. However, nowhere in those standards does it require that there be a risk assessment during design. It's done after there's an exposure event. Then we should be using ventilation systems. So let's talk about then retrofit options and examples. The first thing is to isolate or enclose the process, and a good example might be for metal working fluids or engineered nanoparticles. NIOSH has done a really wonderful job kind of creating design requirements or guidance for engineered nanoparticles that I think predominantly have been accepted and are being implemented. Wet methods, and you know all this from silica dust and asbestos exposures and the use of wet methods to keep exposures down. And then filtration, and that's generally for dusts. Local exhaust ventilation, however, when you apply that, it may require permitting. So if I have a production operation that's using chemical agents and I identify that there's an exposure risk, I'll put in local exhaust ventilation systems that have to go all the way through the roof and then have to be exhausted through some kind of a system on the rooftop. That probably will need environmental permitting. And then the other factor in this is is my general ventilation system adequate to be able to supply all the general ventilation that the local exhaust system is venting. So that's where the whole concept of industrial hygiene for chemical exposures comes into the design of buildings as well. So it's not simply the design of the equipment, it's also the design of the buildings. And then I also have, for general ventilation, ones that you probably all know, it's the forklift battery changing rooms, for instance. And in the interim, again, in industrial hygiene professionals, until we can have the right kind of controls implemented and tested, have to use personal protective equipment. So how do we get to the top of the hierarchy? So during design and specification of new equipment and processes, we have to identify the hazards, we have to assess the risks, we have to design in the controls, and verify the exposures are controlled during full operation. So let's talk about that hazard identification and risk analysis. So the first factor is that an industrial hygienist has to pull every one of the safety data sheets that will be used in that process. And it's not just the ones that can cause health risks, and you can see the images there, but it's also ones that also can cause fire and explosion risks, because those also need to be factored into your design of your building systems and your design of your containment and controls. We have to look at the potential for inhalation and skin and eye exposure. Is there data available for an existing installation? And for new processes and equipment, we have to consider modeling. And then we have to also factor in processes with multiple chemical hazards. Are you skilled enough to take a look at 2 or 3 chemical agents with additive or synergistic effects and make the determination about how low that exposure needs to be controlled? And then we get to the exposure risk rating and tolerances, and this comes again out of the PtD standard. In my humble opinion, when I'm involved in the design of a new facility or a new process, when I'm getting involved in very, very early design, I make sure I remove class 1 and class 2 chemicals. These are chemical agents that are carcinogenic or agents that can cause irreversible health effects at low doses. And it makes sense to just get those out and substitute those right away, eliminate and substitute them. And then, when you do have them, you have to establish what that risk is going to be for the emissions. So if I have chemical agents that have authoritative OELs, I'm going to probably want to control the emissions coming from that if I have a worker standing right at the machine to probably 10% of that occupational exposure limit, and I have to be confident to about 95%. That's a heck of a lift. That's a heck of a lift for industrial hygienists that have to figure out how to design what those emission standards are going to be from that equipment. What we call, we recognize, however, that when we're just doing this qualitatively, if I don't have data, and I'm not going to have data if it's a novel process, it's like throwing darts. And so that's when I said to you I'd like to design it to 10% with 95% confidence. It's because I recognize the way I make pies and the dust. And I don't have that degree of confidence in my qualitative exposure assessment process to be very confident to say this is going to be okay, this is not going to be okay. And so other industrial hygienists, we call it dart throwing monkeys. That's what we are because we don't do this very well. So one of the things, getting back to the whole concept of occupational exposure banding and control banding, is this is a document that we used to do to inform the pharmaceutical industry about how to manage this. If you take a look at the occupational health hazard, mild and reversible to severe and irreversible, the physical form, this was slurry or suspension all the way up to highly dispersed. These are essentially micronized compounds. The task duration, 15 minutes to 8 hours, and then the quantity. And then you start to look at the kind of controls you would use. In the first section at the lower left-hand side, these are usually laboratory chemicals, small quantities. You're going to be okay with some local exhaust ventilation controls. If it's higher concentrations, mild, irreversible, you really don't need anything other than really good general ventilation because it's a slurry. When you start to have more powder forms and you have higher hazards, then you need to have better local exhaust ventilation systems, and there's a ventilation ring around that port where the powders are going through. And then you have here a bag unit, so that the drug active is coming in through a bag down into the system. And then you go all the way up to a highly contained process, where you have split butterfly valves and a lot of really robust engineering controls. And then even down at the bottom, glove, this is vented, these are vented enclosures, and then glove box containment unit. But this kind of really helped inform our design engineers. These conceptually helped them understand where we wanted to head when we had a new chemical process, a new chemical entity. But that has to be designed for your process. So then getting back to the exposure risk ratings and tolerances, That allows you then to get to that hierarchy of the controls. So how do we get to the hierarchy of controls? We actually do prototype development, and requires partnership with process engineers. You have to sit with the process engineers. They have to agree that they're going to design the process so that it controls the exposure as well. And we're involved from project ideation. I mean, that can't happen during detailed design. It has to be at product ideation, and then vendor identification, specification development, and then vendor selection. And then it has to go through an extensive design review. And it has to be initiated early on, a technical risk assessment. What usually is done at 50% design review, and then it's finalized at 90% design review. And then the equipment is built, and we do factory acceptance testing, measure chemical emissions as designed and specified, and does it meet and exceed the specification limit. And then it's tested again when there's equipment that's installed. And it has to have site acceptance testing. And that will help us understand whether there's additional controls that need to be done. You got to have that money in your pocketbook. You have to, nothing's worse than going through ECM, Engineering Change Management, shoot myself in a supplemental CAR. And then equipment launch. During full operation, again, we have to do sampling. And you sample at the point of emission to see whether it met your target, in addition to my personal exposure sampling, so that you can verify whether the worker is protected. And then the passive and active engineering controls, the local exhaust ventilation system, it may require permitting and general ventilation. And this is just a high-level overview of the Amazon process. You can see that each one of these blocks has a much bigger group of activities that need to be conducted. But this is exactly what we then try to follow when we're designing new pieces of equipment. And then finally, once I do find that I have made some less than conservative decisions, and they're still, or we just don't have the technology to design out the noise to the level that I want, which is 77 decibels, then I need to understand how I'm going to revise my specifications. How do I go back and make sure they're even tighter? How do I then work with the material integrators and the the equipment designers to keep these exposures down to below where we want to be? So that's what I wanted to share with you. And thank you very much for letting me talk 5 minutes over.